Good evening, class, and welcome to our next lesson. Today, as you said, as you see in the link, we are going to discuss about the theory part, that is going to answer the questions, the theory question from the pirate paper. And as we answer these questions, we are going to actually check on some concepts that was in that book, that is the theory book. I already said this book to you. I hope you have gone through the book. So in our first lessons, we were discussing about some simple concepts, though there are other details I added, like chapter 1 was not in the book. And if you check on the course outline, actually we start with that chapter 1. The chapter 1 is about introduction to Excel, which this one we did in our first lessons. So, and the introduction into Excel is also highly tested in the theory papers. You're supposed to understand the spreadsheet, the keyboard shortcut, the references, and some of the basic functions that you use in Excel. So I'm not going to go through this because throughout you have been using Excel, and probably in the process of using Excel, you have noted some basics in Excel. Like we said in Excel, what you specifically, where do you apply Excel? You have been doing this, doing forecasting, doing financial analysis, budgeting, and several areas where Excel can be applied. Then you also need to know about the Excel window. This one we already discussed this in our introduction part. And I showed you how to move around in the Excel worksheet. Then there is an additional part about the keyboard shortcuts, the Excel key shortcuts. This now, as you work with Excel, you will experience some of these shortcuts. And most of them are things that you have been using, like to find, to copy down, to do a number of things in Excel. These are things you have been doing. So we have several concepts of Excel. The keyboard shortcuts are so many. So you need to actually sit down and evaluate some, but this one you have to do it using an Excel worksheet. So we are not going to do that one today. Maybe another lesson, we are going to go through those shortcuts. So, and we have seen a number of, we also did discuss about the types of data, the labels, the values, the formulas. We have been using the values in currency format, dates formats, text. We also did application of formulas, where we said that anytime you are given a computation in Excel, you can insert a formula, that expression that starts with an equal sign. The functions inbuilt formulas, where Excel has so many functions. The functions used to perform arithmetic operations. They uses these symbols. We have the arithmetic symbols, the relational symbols, and other operators like percentage, like and so on. The referencing, we discussed relative, absolute referencing. Some of these things have been using them throughout our practice in Excel. So, and some of the basic functions, statistical functions, mathematical functions, like average, sum, median, mean, and each of these has various attributes that the syntax on how you type them. The logical functions, like the use of if function, we did, and some exercises here we practiced. Hope maybe you still remember how we were going about it. The if is divided into simple if and nested if. Then other functions that involve the if function include the sum if, average if, count if, the if and function, if all function. which this we did. We have functions that we use in date and time functions. And we also discuss about lookup and reference function. That is the VLOOKUP, the HLOOKUP, and match and index functions, which again we apply them in Excel. So this is the part that you are referring to as introduction to Excel. So after that, the next discussion is about the chapter 2 about the introduction to data analytics. And here, the first thing you discuss is about the cross-industry standard process for data mining. So the term data mining is a process or is a term that has been used to mean gathering of facts from a large volume of data. So in every organization, they must create a data mining mechanism. The mechanism that assists the organization to compile the data and to analyze. Before you do data analysis, you must gather this data. So that concept we call the cross-industry standard process for data mining is actually a process for data mining. And it is a proven way, a guide that most industry can use to gather this data, to do data mining. Just like the word mining here means extracting, to extract a large volume, that is extract from a large volume. So the same case in data, you can also do data mining where you extract specific data concept from a large volume of data set, the big data, we say that. So you can do this using this guided rule, that is a specific guideline that shows how you can achieve data mining. That way we are referring to this as a data mining life cycle, because during the process of data mining, you follow this life cycle. You start by doing what? First, you start by understanding business, the business understanding. Then from the business understanding, you'll be able to understand the data. Then you prepare the data, you do data modeling, you do data evaluation, and finally the deployment. So that is a cycle that we use during data mining process. So understanding the business is actually normally done by doing a thorough study in business. That is, you can do a research. That is, you do an analysis. This specifically is normally done using the data finding techniques like having questionnaires, then doing the customer interviews, product evaluation, and so on, the market, checking the market demographics. So, and when you are doing this, or in the concept of understanding the business. So in the entire shell, so what we are supposed to discuss in our case is data modeling. That is, after you understand the business, you understand the data, then you prepare the data through data modeling. So it means a process of data modeling simply means that process of creating a data model for data to be stored in a database. So before data is created and stored in a database, it has to be prepared, it has to be created. So the creation of data will not just happen as a single process. It involves a series of stages. That is what we are referring as data modeling, is a series of 3 stages that you're going to check here. So, and the end of this data modeling will help us to come up with a data model. The data model will be created in a database management system. That is a program, a software. So, and that process of data modeling, that is the data modeling, will involve 3 stages. That is, we will have to develop a data model by involving those 3 stages. The first stage of data modeling is creating up a conceptual data model. conceptual data model. So when you talk about conceptual data model, this is a model that identifies the highest level of relationship between entities. And it simply means that this data model or the conceptual data model is a set of simple shapes. And it is normally done using diagrams. It is drawn on a whiteboard or on a piece of paper. That the database management designer will always start by defining a diagram. The diagram that shows these rectangles and lines that shows the relationship between entities. An entity here means subject of discussion. So meaning a conceptual data model identifies that highest level of relationship between. For example, in this case, we are given a data model that involves time, product, and stores. So these three entities are now the subject of our discussion. That is, what are we looking at? We are looking at products. We are looking at stores. We are looking at time. All of them are connected together by one entity, that is sales. That is what makes or what brings them together is sales. So meaning that a conceptual database or a conceptual data model only represent that art shell, that is the physical, the skeleton of a data model. That is not detailed, it is not detailed. So the square shapes here, we say they represent the entity, and the lines here represents the relationship between entities. That is, there is a connection between product and sales. There is a connection between time and sales, and there's also a connection between the store and sales. So one advantage of using this conceptual data model is that it is very easy to make changes. In case you want to change, you can rapidly update this, and it is easily drawn, it is easily identified. And remember that it is the first stage of developing a data model, that is creating that skeleton. So when the database designer is establishing the database, the first thing is to highlight. So how many entities will our database have? If the database is about selling of products, as we have seen here, then it will have simple entities like the stock of sales, the product. Probably you have other entities like customers, which will also be connected to this. So you can have as many entities as possible in one database model. So here, from this above diagram, then you can see that all the information shown via the conceptual data model is entity. That is, the only thing we are shown here are entities. Entities are now the main subject of discussion of the database. That is, when you are making this data model, what are you involving? That is what is involved in this model. What is involved in this activity? If the activity is about service, then we don't have products here. We will have service. We will have like a school database. We will have the inquiries of students. We will have students. We will have courses. We will have the subjects, the units. So we do not have products. That means there are those things that are involved in that database. Then after the development of this, the next database model is logical, which is the next stage. The next stage of data model, where we said that a logical model describes data in a more detailed manner. So we normally say that a logical database model expand the conceptual database model by adding more details to it. That is, whatever we had previously there, we add more details. What is lacking in our previous model is that we don't have more details to these entities. We don't have attributes. That is, when you're talking of product, what are we specifically referring to? Which products? Which columns are involved in a product design? So we don't have those much details. It is easy to understand this model, conceptual model. It is easy to enhance. It shows only entities. It is abstract. That is relationship only shown, showing that action. That is the outline. And in the conceptual data model, no software is used. We don't have any software used here. It is only drawn in a piece of paper or a whiteboard. But in the logical database model, then adding of these details that every entity will have a list of attributes. That is, will take time and its attributes. You take products and its attributes. That is expanding this. That is logical model. We will describe the details. It includes all entities and relationship among them, or attribute for each entity are specified. Then other entities like the primary key for each entity are specified. The foreign key and normalization. I want to explain this in a diagram that it is the same data model that we found in the previous. But now this one has more details. It is expounded. So in which manner that this model include entities. Initially we had entities, but we never had attributes. That if we are referring to time, we are referring to specifically what? The date description, the month description. If it is product, we are referring to product IDs, product description, categories. Yeah, so we have more details about our products. When a database is represented in this manner, then we call it a logical data model, a logical data model. So this data model, we said that it actually shows the details of this data and the type or the kind of connection between this data established through specific fields. And this, we call them the attributes. We've seen that there's one attribute above here, and then the line, the attribute above here and the line. So that attribute that is above is referred to as the key field or the primary key. That is the field that you help to uniquely identify records in this specific data, these specific entities. So meaning that if you are referring to products, then you have one column called product ID. That column that you help to create the uniqueness of each entry or each record in that database. So meaning that that is what you are referring to here, that it includes all entities and their relationship. It also includes the primary keys for each entity. That is, the primary keys are normally applied to help create the uniqueness of each record in a database. So meaning that if you are referring to products, then every product must be given a unique identifier. This unique identifier is its ID. And that ID, the index, is stored in the product ID. That is, product ID is then our primary key. So sometimes you have primary keys that are repeated in other entities. Like in this case, we are given product ID here, which probably may be repeated again. Like you see here, we have store ID, which is repeated again on sales. Product ID that was in this table is repeated again down here. And you can actually see that product ID repeated in sales, and product ID initially was in what? It was in product, the product entity. That product ID in cell is written FK. FK here means the foreign key. So the FK for store ID in sales is the foreign key, and the date is the foreign key of this. That will help us to establish the relationship between the three entities. So, and that is what we have just stated here, that these foreign keys identifies the relationship between entities. Then memorization occurs at all levels, which actually check more about these memorization. So that is one thing about the logical data model. That is, it is different from the conceptual model in that this model has additional details. It actually expands. It expands the conceptual model. The steps of designing this logical model: first, you have to specify the primary key for each entity, because the entity was first identified in the conceptual model. Then you find the relationship between different entities via the primary keys and foreign keys. Then find all attribute for each entity, resolve many-to-many relationship, and then do normalization. So those are the basic steps that are done during the process of establishing a logical model. Again, we don't need to use the database management softwares to establish a logical model. But sometimes we have softwares that we use to design, just to design, but not to create. So comparing the logical model and the conceptual model we discussed there earlier, then you have several differences between these. So one, we say a logical data model, primary keys are present. But in the conceptual data model, there are no primary key present. In logical model, all attributes are specified within an entity. No attribute is specified in conceptual model. Then the relationship between entities are specified using primary keys and foreign keys in logical model. But in conceptual model, the relationship are simply stated, not specified. So we can simply know that there is a relationship between two connections, but we don't specifically state which of these or which this relationship identified. So that is the relationship between the models, the two models. So then we'll proceed and we'll check on the next database model, that is the physical data model. That is the last stage of creating a data model. So if you check in our course outline, maybe let me share the course outline. Someone is saying I share the notes. I have not shared in any file, because this file, you already have it. It's there in your group. But probably I will share the materials I'm using to explain. Then you download. Just a minute. I want to share the. If you check very well from our course outline, then you realize after the description of whatever we have seen there, that is this physical model, you realize for the physical data model, the model represents how the model will be built in the database software, how you build the database. That is, you design using a simple skeleton conceptual, you add more details in the logical model, then finally, you come up with a structured database. That is, a physical database model shows all tables and structures. If you check the diagram representing the physical model and the logical model, they are somehow close. But here, we refer to this one item as an entity, and whatever is inside it, we refer to it as attributes. But when you are referring to physical model, then it is different, because in physical model, we don't refer this as an entity anymore. It is now physical items, and it is actually referred to as a table. Where we have one table, another table, another table, another table. Then those tables, inside them, we have what you call the columns. The columns. So meaning that we have a column representing the dates. And if you check very well, you realize that it has the date, ID, plus the data type that will be invoked. This date will carry data in which manner? Form of integers. If it is that date description in form of varchar, that is combination of numbers and text. So this database model is actually achieved using now not a pen, a paper, or a whiteboard, but you usually apply this one using now the database management systems like the SQL, the Oracle, and any other database software that you can use to establish a database. So if your physical database model shows all tables, structures, including column names, the column data type, column constraint, primary keys, foreign keys, just like we have seen previously. So the features of this physical model include, first, you specify the table and the columns. Whatever we are referring to as entities, now here we call them the tables, and they have the columns. The columns, some of the columns will be the foreign key, that is primary key repeated in other tables. Then you have to do denormalization, that is, it may occur based on the user requirements. Then the physical consideration may cause the physical data model to be quite different from the logical model because it is established now using a software. So you can use different application, that is relationship database management system. And examples of these programs you can use, we have MySQL and SQL Server. But these are the softwares that you can use to establish a physical data model. By establishing a physical data model, then you come up with a database. And that should be the last stage of establishing the a data model. So the step of creating this, first you convert entities into tables, then you convert the relationship into foreign keys, you convert attribute into columns, that is from the logical model, then you modify the physical data models based on the physical constraints and requirements. And once you do this, you'll come up with a simple database structure like the one we have seen here. So that is how you establish the data model. So comparing the physical model shown in this and the logical model, then the main difference, we say that entity names are now table names. Attributes are columns. Data types for each column are specified. Data types can be different depending on the actual database being used. So, and that is the concept of data modeling. You know, that is something that is actually shown in our book. And the data modeling said we have two types of data modeling. The entity relationship is what we have explained. Entity relationship model is where we use the entities. The entities could be like what we are referring to as products, as time, as sales, as store. Those are the entities. So meaning that data model is defined as that abstract model that is not physical, non-physical model that organizes data description, that shows how the database will look like. They are actually the building block. Is an architecture that before database is built, then you must create that architecture of the database, the design of the database. And you do this one using data modeling. So, and we said we have types of data models in database, and we have explained the three. That is the conceptual model, the logical model, and the physical model. So I've used a simple language that will help you understand that a conceptual model, this data model defines what the system contains. That is the entities that the system should have. We talked of the entities like in our previous year, we said that the entities we are using to develop a simple database model, like what do we need to have? Time, we need to have products, we need to have sales, we need to have stores. That is what we are referring to as what the system should contain. So this model is typically created by business stakeholders and data architects. The purpose is to organize the scope, actually the structure, the main skeleton, and define the business concept and rule. Then the logical data model defines how the system should be implemented, regardless of the database management system to use. And here we say that it expands this by doing what? By adding more details to the conceptual model, that is including the attributes of every entity. And once you do this, then you understand your database in a clearer perspective. Then finally, we will have the physical data model, and this describe how the system will be implemented. That is, how do we implement now the final database? And this implementation is done using a specific database management system. And here we talked of softwares like MySQL, we talked of SQL Server, Oracle, and other database management systems that we use. As if you check from our course content, they also highlighted a few of these database management systems. So you can check from here, you'll find those systems. We talk of database, the database management systems. These are the systems that are used to perform or to create a database. But before you reach to this point of using the SQL or the Oracle, then you must have already designed the database. You must have a conceptual model already created, then again enhanced to a logical model. Then the physical model will help you now establish a database using these tools. That is what we are referring to as the database system. So, and I think that one is clear. So after that, then we are supposed to, now we have already explained. Now here I'm using a simple diagram to show how this connection happens between the logical data modeling, the physical data modeling, and the conceptual data modeling. There is that relationship between the two. So the explanation of each we have already explained. The entities, and we have the conceptual data modeling. Here we have this connection using the arrows, the logical data models, which we explained that you add more attributes in the logical model. Then finally, you create a physical model where you must use a database management software. So that is what was in that explanation. And I hope that explanation is now clear. As you go through it, you'll understand that. Then the advantage here is that now, when you're looking at each of these, like we start with the conceptual model, then in this book, I have highlighted some of the characteristics of it. It offers organization-wide coverage of business concept. These type of data model are designed and developed for business audience. The conception model are developed independently from the hardware. They are not connected anywhere with the hardware. There's just a separate design, normally done on a piece of paper and or a whiteboard. is a structure, is a diagram. So, and each has its characteristics. If it is a logical model, it describes data needs for a single project, but could integrate with other logical data model based on the scope of the project. It has attributes, data types. It actually enhances the previous, designed and developed independently from the database management system. The conceptual model is developed independently from the hardware, while this one is developed independently from the database management system. Because the third one is actually developed or created in database management softwares. So the last physical data model is actually designed. It is developed for a specific version of DBMS, that is database management software. So, and that is basically what data model is all about. So the reason why we have discussed this, because I have noted as you go through these past papers, a number of questions has been framed about these database models. And without the basic knowledge, that is that information, then you have challenges to answer those questions. And it is important to understand the concept behind those models. So we are going to discuss these questions now, because now once you have the concept, then you can go through these very, very fast. Then before we finish that, then our next discussion, we have the advantages of data modeling. That why do you create data models? So we have seen that before you develop the database, you must start with data models. You have to create a model. A model actually helps you to have a clear understanding on how the database will look like. And once you create the model, then you will not have errors during data development. And because of this, you have already realized a clear connection between entities. You'll be able to identify that there is a connection between one entity and the other through a specific field or attribute. So, and it is important to create these models. So then, that is actually the first part about this database modeling, and we can now check a few questions, then we proceed. So question number 1 from the pilot paper, we were told which of the following choices provided is provide the correct definition of a data model. That is, what specifically is a data model? So we have seen different definitions of data model. And if you look, when you're answering your questions, one thing that you should make sure that you do for the theory part, for these 40 marks, make sure at least you have 20 marks. You have at least 20 marks from the theory part. Because if you get 20 marks from the theory part, then you attempt like 2 practical papers, then that is already a pass. But if you fail this theory part, then it simply means you have to do all the paper, all the questions in section B, of which sometimes would not be possible to maybe to gain all the 20 marks of every question. So that means the theory part will be like your savior. If you're able to at least score more on the theory part, then the practical part, you just be required to identify just 2 or 3 questions that you are very sure about out of the 5. So you are supposed to read all the 4 choices. Don't just read one. You read all the 4 choices, because most of the question you are asked to either choose the correct definition or maybe eliminate the wrong one. So, and here we are told to choose the correct definition. Is the data model a visual representation of data objects? We said a visual representation of data object is actually referred to as data visualization. And here, a very good example is a chart. When you are creating a chart, That is a visual representation of data objects. Then an organizational data object, can you say that data model is an organization of data object? Can see, maybe we'll check the others. A conceptual representation of data objects. So if you say conceptual representation of data objects, then here you are defining a specific data model, that is conceptual model. Because a model is not only conceptual representation. We have three models: conceptual, logical, and physical. That means at the end, you have actually a physical model. That is something that is already in a database management system, a solid, something that is solid. Then a graphical representation of data objects, again, it's just the definition of the first one, because a graphical representation of data objects is actually a diagram or a graph. So, meaning that you are left with one choice that is very clear, that when you talk of a data model, we are referring to that organization of data objects. That organization of structuring of data objects is what we call a data model. So, and you go and to deep discussion of this, and you'll get to understand more details about data models. And here we can actually see that data model simply here means or defines as an abstract model that organizes data descriptions, data semantics, and consistency and constraints of data. That is a way of organizing the data. Okay, the data model emphasizes on what is needed, how it should be organized. So that means that organization of data is what we refer to as data model. Then, question 2, you are to the cross-industry standard, the process of data mining requires data analysts to understand the business, which we said it is the first step. As the first step, which of the following component does not form part of this activity? That is, which of these will not form the part of understanding? That is what we said here, that when you are running or you are running this we call the cross, whatever. So it's here. We start with business understanding. The business understanding. So I have not expounded more on what business understanding is all about, but you need to check for a person to understand the business, what specifically, which activities he or need to do. So, and here is only one activity that is not involved in data understanding. So meaning, then you must do what? You must expound this. You say that, specify the goals and requirement for data mining. That is actually an activity that is very crucial in understanding a business. You must first know the goal and why you have to do data mining. Then an overview of the available data and their quality. Overview of available data and their quality. Then you have the other one is inventory and resources available. Then cost benefit analysis. Then here we are told to give which of these is not actually an activity involved in understanding the business. So now here you have to use elimination method. So that we see, we talk of the overview of the available data and their quality. If you understand the overview of available data, that is, which data do you have? To understand the business, you must understand the data. That is what is already there, what is available, and their quality. Then an inventory resource available. Then cost benefit analysis. The cost benefit analysis is normally done to understand the added value. That is the value added to the data that you already have, or understand the business in the concept of value addition. So that is it viable or not viable? So meaning that some questions are very tricky and you must actually analyze, and you come up with one, the specific one that is not actually part of understanding the business. So I don't know which one you select. Maybe you can argue out and come up with one. So which one do you think that is actually not, will not form part of understanding the business? So now here referring to the first stage of data, that is business understanding. So if you check very well, you'll find that the last one is actually one activity that is involved in understanding the business. That is, you must actually understand the cost benefit. That is, you also need to evaluate a specific goal. By doing that, you understand your business and the overview of available data and their quality. If you check this one very well, you'll find that probably this one will be used in understanding the data. That is the data that you have is actually the next activity. In this process, we have business understanding, and which is closely connected to data understanding. That means a process of understanding the business too involves the process of understanding the data. Then we can also say that is also an activity involved in understanding the business. So the odd one out could be the inventory and resource available. The inventory and resource available. So that will be the odd one out. Then the next question, we are told to choose again here, which of the following is the most common goal of statistical modeling? The most common goal of statistical modeling. So on here, we have to use the elimination method, and statistical modeling here we are referring to now this more digital, whereby you analyze the data after running a statistical analysis. So if you check this, whatever you are given, we have descriptive analysis, we have the subsetting and risk analysis. If you check those three, then you find all of them are connected to statistical modeling. And then, meaning that the odd one, that is the most, we are told the following is the most common. Which of the following is the most common goal for statistical model? Which of these is the most common goal? That is, what is the objective of running a statistical modeling? So here you have to select specific, that is, what is actually most common. And you will find that all of them are actually objectives of running a statistical modeling. But now here you are told to give the most common, the most common. So if you check in every statistical modeling system, you always find the descriptive analysis. And this is actually the most common, the most common goal. Not really, sorry. That is the most obvious things that you find in data modeling. But the process of data modeling is actually actually help us to do what? To do what we call the business insight. That is to understand a business in a more and a detailed manner. And which we say that inference, the business will gain this inference in running statistical model. And actually, the biggest goal is to help to get clear perspective of the business, and this achieved by inference. That is by understanding the business in a deeper way. So here, the most common is the inference. So that is the most common goal of data modeling. So then, the next question, you are supposed to use the pattern. Just a minute. You are told here that a collection of interesting and useful pattern in database. A collection of interesting and useful patterns in database is called what? So if you say data set, information and knowledge, or analytics, then first you have to understand what is business analytics. So, and if you go back to this book, then you scroll down. After the data modeling, the next discussion we discuss here is about business analytics. That was chapter number 3, after the stages of data creation, and then big data. Then after the big data, the next concept is about business analytics. And what is business analytics? Here we say that that analysis of data is very vital process in business. And we have 3 types of data analysis. We talk of which business analytics or data analytics, then we are referring to that practice of examining data to answer questions, identify trends, extract insights. And when this analytics is done in business, is what we call business data analytics, the business data analytics. So, meaning that effectiveness of analyzing the data so that we can answer some questions. We can identify some insight. We can identify some trends in business. That business analytics. Now here, we are told that when you gather the data in a specific sequence, and we go back there, and that collection of useful patterns in the database is what we call the analytics. The analytics is actually that useful pattern, the useful pattern in database, because a data set is actually a collection of data, not patterns. Information is actually that data that has already been computed, that has already been processed. And the knowledge is what you get after you go through the information. The information or the knowledge is actually onto the person. That the knowledge is only achieved after the person or that human goes through the information. But that pattern that is established on the database is what we call data analytics. Why have this pattern? Because it will help us to understand the data, to help us to actually analyze the data in a clear way to identify the trends. So that is analytics. That is what we call analytics. And the next question, you are supposed to, which of the following is included in data cleaning report? Data cleaning report. What is included in data cleaning? What is data cleaning? So if you go through this again, we also discussed about data. Okay, there is a concept about data cleaning, and of which when you're running data cleaning activities, data cleaning, we say that process of fixing or removing incorrect, corrupted, incorrect format, duplicates, or incomplete data within a data set. That is data cleaning. It involves fixing or removing incorrect or corrupted data. But it goes far much detailed than even modifying the already inserted data, still involve data cleaning. And we have so many activities involved in data cleaning. For example, the removing of duplicates and irrelevant observation, that is data cleaning. The fixing of structural errors, some errors that maybe probably that were incurred during data entry. Okay, for that structural errors are when you measure or transfer data and notice some strange naming and conventional typo errors. Like most of those tunazipata, even for Excel, like such errors. So when you fix such errors, then you're still doing data cleaning. The filtering of unwanted outliers, that is often the will of one-off observation where at a glance do not appear to fit within the data. There are things that you just check at a glance. Maybe the figure that has gone beyond the normal figure. Maybe you are working with thousands, then you find one figure that is going up to millions. Then that is something that you can identify very fast. And removing such, handling missing data, that in case you had missing data, you need to check and look for that data. Sometimes you do ignore, but during the arithmetic, during the statistics, then if you ignore the missing errors, then your statistical results would not represent the actual results. So meaning that sometimes it is important to note that even during analysis, the missing records also assist in giving a clear image of how our data is. So meaning that if you have some missing records, now because probably during the process of gathering the data, like the questionnaires, the respondent did not fill some questions. Maybe probably he did not understand the question, or maybe the question did not apply to them. You should not assume that maybe it was just a missing record and then you put your own figure there. So you have to involve even those missing records during your analysis. So the validity, that is validity of data, here we are referring to the correctness of data. So it is important to check on this. That is still process of data cleaning. So it involves those few activities we have seen there. Getting rid of unwanted and verifying data structures, unifying data structures, standardizing your data, removing unwanted outliers, fixing cross-set data, removing type conversion, dealing with the missing data, and validating the data. All these are activities involved in data cleaning. Now, we have now seen what specifically what data cleaning is all about. And hence, if you are told here to which of the following is included when you do data cleaning, you have to produce a report. And in that report, you should have one of the activities that is here. That is what you are asked. What should you include in data cleaning report? Do you include the data structure? I don't think you really need to display that. Data content, do you not need to display the data content? So what do you need to display in the data cleaning activity? Then after the evaluation, then you find that data cleaning activities is what you need to show in your report. Which activities were involved in your data cleaning? Probably your data had a lot of duplicates. Maybe you had 1,000 records. After data cleaning, you'll find that maybe you have just 500 records. Then you have to include in your report why from 1,000 to 500, because you did an activity. Which activity? Data removing duplicates. That is something that you need to include in your report. Then the next question, you are supposed to give some shortcuts, their meaning. Which of the following key shortcuts or the short key functions will analysts use in Excel to paste the content in the cell? Now that is very easy, surely. And each of these, if you use Control F, that is for find. Control V is to paste. Control C is to copy, where Control U is to underline. So that means every shortcut here has a meaning. So here we are told to give the paste function, which is Control and V. Then again, we are given another question about functions. And here we are told the following statements relate to the formula for computing the standard deviation in Microsoft Excel. And in standard deviation, when you are computing this, most of these function comes with a letter at the end. So standard deviation dot P, this compute the standard deviation of the entire population. P here means population, where S means sample. Where there is S, we say it computes the standard deviation of the entire sample, while the standard deviation dot P actually computes the data of specific of the entire population. So the standard deviation dot A is for all data, compute the standard deviation of the selected sample. So, and these functions are actually visible even when you're using Excel. Probably that was a free mark, because if actually you are not very aware of it, you can even now cross-check with your Excel application and check of these functions, which one is actually stated the right way. And how do you do this? When you open your Excel program, you can just start, set up the function here. If you say equals to standard deviation, you'll find them here. We have dot P, which is the standard deviation of the entire population. P means population. Dot S, estimate the standard deviation for a sample. So there you choose the sample. Well, dot A here represent the standard deviation based on the sample. Now, including the logical values, text, that is all the data. That is as compared to the first, which ignores the logical values. And the first one again ignores the logical values and text. But for A, it includes all of them. So that is the difference between those. And now you are told to do what? Which of the following choices is correct? Which of these choices is actually correct? I don't know whether there was a spelling mistake here or what have you, because if you check this and this, they are just the same. That both of them leads to compute the standard deviation of the entire sample. Entire sample, where one should read entire population. Yes, they had stated that probably after analyzing those three, then you can pick 2 and 3. And 2 and 3 will actually seem to be, because this is for entire sample. But 4P is for the population. That means if you use the sample here, this one will be wrong. So which then will be correct is the one that referring to sample, where this compute the standard deviation of the selected sample, meaning that the entire sample, and that still is correct. So meaning the statement 2 and 3 are correct choices. So then the next question we are told, which one of these function is not an array function in Excel? Array function in Excel. And talk of an array function. These are a function that deals with a set of values. An array here means a table or a compilation of cells that have data. So meaning data represented in a group of cells. So most of these functions actually include the array. Multi function this will include is actually an array function. The transpose will help us to convert an array of columns into row. That means a group of cells from either rows to columns or columns to row. The VLOOKUP will always work with an array. So meaning, as you type these functions, you actually find those that if you say like M multi, and you'll find this function here that returns a matrix product of 2 arrays. That means it's an array function. So if you check another function like the VLOOKUP, then you'll find that when you're working with the VLOOKUP, then it will look for the value of the leftmost column of the table, meaning a table. There is an involvement of a table. And even when you are dealing with this, you'll find table array. That means the function again is working with an array. An array here means that when you're working in an array, you'll be referring to a range of cells. That is what we call an array, a range of cells, the table array. So meaning that again is an array function. Then if you proceed to the next function, that is transpose, then again you find transpose, again you have an array. Because the transpose will help you to convert the vertical range, where here range represent again an array. And when you are working with this function, it will automatically ask you for the array. The array here we have said that is a group of cells that are being involved in this function. And actually transpose always asks you the array. So meaning again is an array function. So simply meaning that all those 3 are array functions, and none of the above is actually the right answer. That which one of is not an array function in Excel. All of them are a function in Excel. So if you say none of the above, is that the right answer? Do you say that will be the right answer? That will be the wrong answer. That is another wrong answer, because if you say none of the above, it means all of them are not array functions. You see that a very tricky question, because I told which one is not. an array function in Excel. Some of these questions you have to be very keen. You have to actually understand this question in a clear way. So if you say none of the above, then you simply say that none of this is an array function in Excel. If you say multi, we look up. Now probably that question you'll have to check those that are very closely connected to arrays. So according to the question and the answer, I think there was a problem here with setting that none of the above. None of the above. Okay, that was the given answer. But if you check, if you say none of the above, then as you answer the question, it means none of the above is actually an array function in Excel. Which one is not? Is not an array function in Excel, is not. Yeah, then the answer is correct, because if we are told is not here means all of them are array function in Excel. So meaning that none of these above is not an array function in Excel. Okay, now I get the concept. Yeah, so yeah, it is okay because none of them is an array function in Excel. Then we proceed. We say that the question number 9, dash is the basic data structure that can be thought of in an SQL table or a spreadsheet data representation. So which of these is the basic data structure that can be thought of, meaning that can be used, can be applied to, or can be used in SQL tables or in a spreadsheet data representation? So a series, a list, a data frame, a point. So here you have to be very careful, because when you talk of a series, when you're talking of data representation, you remember very well that in Excel, especially when making the graphs, when you are making charts in Excel, then the data represented in form of series. That is, you may have one variable here and another variable here. Let's call it X and Y. And when you are making these variables of X and Y, of course, you'll have some data. You'll type this data. Okay. You have this data. Let me have them here. So here we say that we have the category, and here we have the values. And the categories, you can represent them as letters. Then you're supposed to show the categories versus our data. And when you make a simple charts, for example, in Excel, and you produce, say, like a column chart, could be a column chart like this one here, then you realize that these we call series. What are these? The columns you are referring to here are series. So these are series, another series, another series. And that's what you're referring to as series. And hence, we are told that a specific one of these is a basic data structure that can be thought of either in SQL or in a spreadsheet data representation. So there is nowhere in a spreadsheet you use a data frame or a list. Points, we're not very sure, but points here represent maybe that measure of the size. But a series is actually one of that basic data structure that can be applied specifically in spreadsheet representation, a series. Then the other question, which of the following component does not fall within the real of velocity in the big data, big data. Big data. So you say the big data. What is big data? So when you talk of big data, we are referring to that compilation of a large amount of data. So if you check the concept of big data, then you'll find that the collection of large volume, that collection of large volume of data, we can refer to it as big data. The process of big data is to make sure that you manage those large compilation of data, either structured, semi-structured, could be structured or semi-structured. So, and is that concept of big data is actually just below the business analysis. Yeah, the structured, semi-structured, that combination of structured, semi-structured, and structured collected by an organization that can be mined for information and used in machines. So, and if you check, we have several concepts of big data. And during this discussion of the big data, we finally found here, referring to the big data being structured, we also refer to the size of the data, the capacity in which this data will occupy and such. And we talk, that is just definition of big data. But as you go into details of this, then you said that the big data has the several characteristics that when a data is referred to as big data, if it is occupies a bigger volume. Variety here means that it checks several aspects of life. So as you've seen there, and each of these actually it explains about when we talk of velocity, we are referring to the speed at which this data is generated, processed, and processed to meet the demand and the challenges that lies in the path of growth and development. So that is what we call velocity. And in the question, we are now asked to state the component that does not fall under this velocity. The process falls under the velocity. Because it's talk of generated and processed to meet the demand, the speed at which data are generated, and then the streams here, referring to this data sometimes moves in a streams or a sequence, a series of operations. So we have the streams. The real time again is connected to velocity, because the reason why we connect real time systems and facilitate the speed. The speed, that means, is also a component that falls within the velocity. But the terabyte, this one does not fall under velocity. It actually falls under the volume. So meaning the odd answer out. Then the other question 8. Then we talked of terabytes. Say terabyte. So question 11. Question number 11. I hope the sound is okay. So we check the next question. Then question was asking to provide the right V that provide the data is being authentic, trustworthy, and original. And if you check all these V's of data, then you'll find each one of them actually explains something. And hope you went through all of them. When you check veracity, what do you mean by veracity? Here we say that veracity, the truth or accuracy of data and information assets, which often determines the executive level of confidence. So simply we can say that veracity is the right answer. Then the next question, question 12, the following statements relate to the definition of the type of data analytics. That is, number 1, descriptive analytics provide historical data and information. Prescriptive analytics provide data and information for this decision making. Predictive analytics provide data and information to explain deviation from expected. And here you are told which of the following is correct answer. So which of these is actually the right answer of this? So you need to actually understand about those analytics. We did discuss about those 4 types of analytics. which if you remember very well, we said if it is descriptive analytics that answers the questions like what happened, what really happened. So, and in this type of analytics, then you can simply say analytics. Simply say this, just a minute. Need to check on the cross check on that. So that descriptive analytics interpret the historical data and identifies the trend. That means the first was actually true. That descriptive provide historical data and information. Prescriptive provide data and information for decision making. Does it do that? Then you can say that prescriptive use statistic to focus future outcome. So when you relate to that, you see there is a relationship. Then predictive is prescriptive. Prescriptive, you say that prescriptive applies application of testing and other technique to determine which outcome it will yield the best results, that is under given scenarios. Of course, you can say that it can help us to predict, then predictive uses to forecast the future. Then according to this, then you can say, and after analysis of this, then you can say only statement number 3 is correct. That is prescriptive analytics provide data and information that explain the deviation. Now here you're told you're supposed to, the following statement relates to this of statistics. Which of these answer is the correct answer? Which of these answer is the correct answer? Which should be the correct answer? Because matter of fact, if you check, the first answer is actually correct. The descriptive analytics provide historical data and information. Is actually very correct first answer, because it does that. It describes, it interpretation of historical data and identifies trends and patterns. Identifies trends and patterns. So that is the prescriptive analytics. But the rest, if you check both, they are not correlating with already what we have. So meaning that they are not really defined. So the which one ranks the highest among these data analytics? We say that during the data analytics, we always start with the first one, that is descriptive. We say they have to follow that order from descriptive, diagnostic, prescriptive, and yeah. So meaning that here, the one that should be ranked the highest is descriptive analytics. Descriptive analytics. Descriptive analytics. It should be ranked the highest. Then question 14, which of the following is not a data cleaning strategy? Initially, we talk of data cleaning activity, but now we are looking at data cleaning strategy. Removing incorrect data is actually a data cleaning strategy. Removing duplicates data is another data cleaning strategy. So fixing data with the structural errors and also filling in for missing data. If you check here very well, you find that almost all the answers could actually be described as correct answers. Because if you check this, then we say that removing incorrect data is still a data cleaning strategy. When we talk of strategy here, we means a unique plan of data cleaning. The removing duplicate data is something that must be done. Then fixing data with structural errors still involve data cleaning. But filling in for the missing data, I probably maybe will say we cannot prioritize it as a data cleaning strategy. Then question 15. Which of the following is not a data clean? So we have done that. Then the next question we are told, which of the following software will a data analyst use to clean the data? Data cleaning tools. We'll actually see those data cleaning tools. We have these three softwares. Data Stage is one of the data cleaning tools. If you check here, then you'll find that Data Strange is actually one of the tools that we use to clean. All the others, SQL is for developing, Tableau is for visualization, and Microsoft Strategy, again, is another tool that we use to do what? To visualize the data. Microsoft Strategy, that is a data visualization tool. Activities applied in data visualization. Visualization, we said, is a concept of which under which data is represented in form of figures. Data is represented in form of numbers, and that is in form of graphs. Yeah. So we have that question about the activities applied in data visualization. We talk of data visualization, then this is another concept again. And we said the visualization will involve doing what? Graphing our work. And you can use several visual editions there to do the same. So meaning visualization is actually improving your data to make it easily understood by different categories of people. And in our question, you're supposed to actually say that which activities, following activity apply to data visualization. Those format, content, structure, and purpose. Which of the following is correct order of these activities? Where do you start? So anything that starts with the 4 is a likely choice, because you first identify the purpose. Then after identifying the purpose, then the structure, the format, then the content. So you start with the purpose, You set the purpose, you set the structure, the format, and the content. Format and the content. That means choice B then is fine. When question 17, it remain with maybe just 2 more questions. And here we are told which of the following graph would likely present better relationship between a data visualization. That is, which of the following graphs would likely present a better relationship between variables. So the chart that shows that good relationship between variables, we have the start, the progress. So here, we are told to give that chart that represent the relationship in the best way possible. So, and if you use a progress bar, it actually shows us that relationship between the set of variables given. Then question 8, so here we say this progress, the progress line graph is just like a histogram or any other graph, or that is a graph that made of lines. So which of the following correct define composition of data visualization? Data visualization method of presenting part of the whole relationship of data and information, of which we are told to is collect that defines composition of data visualization. So that is the method of presenting a part of the whole relationship of data in an information. Then you have question 19, where you told the following people in an organization will least likely to be involved in implementing data protection laws in a country. Then you are told to explain which of these people in an organization will least involved in this. Remember that data protection law is protection against the data and data users. So meaning that the check risk officer, those normally checks legal officers, and the chief information officer, all these are connected to the system. The chief executive officer is not connected much to the system, though you must understand the system running, but you don't use the system on day-to-day life. Then question, the last one, under the data protection law, organization will have to take steps to demonstrate they know the data they hold, where it is stopped, and who is it to share. So, and this is referred to as what? So we already discussed about database several times, but we need to discuss and expound further about data management. Seen several questions from there, it is important to understand about those concepts and terms used in data. And so I'll check more on data management, then I'll have this one again, we'll discuss together. And today I want to wind up there. So in our next class, we'll just do we'll go through some basic part of the the theory again, but you're going to tackle one question, practical question, and we also attempt the 2021 theory part, plus other cuts that you did. We also need to go through those cuts. So as for today, we are going to stop there. And the assignment I'm giving is you go and check on the theory part of the paper that was done in our last sitting. Just go and check that. Try to answer those questions. As I send that small booklet I was using to explain data models, but now you'll get it in Word format. I don't know whether it will really show this. Someone is asking whether we will have class on Easter. Easter is not this weekend, it is the other weekend. So we still have a whole week to go, and we'll check on that and reason that out together properly. The data I'm sending is a file that we are using to discuss about models, data models. So the assignment, I have given the assignment. It said go and attempt that paper 2021. Come already usha attempt, you can have, or you can send your inbox, your file, and then I will check and I will send you some results or some explanation to your phone. So I've already sent that file in that platform, and I'm sending another file on the group. You just check there, download that file and read it through. Don't just print and keep it. Just remind yourself on remind yourself on those exercises we have done so far. So you get the file, download, then see you in our next lesson.